Here are facts about Fused Deposition Modeling, FDM. Fused Deposition Modeling, FDM, is a 3D printing technology that was invented in the late 1980s by Scott Crump, who later co-founded Stratasys, a leading manufacturer of FDM machines. FDM is an additive manufacturing process that works by extruding a thin filament of thermoplastic material through a heated nozzle, which then deposits the material layer by layer to create a 3D object. FDM is also known as fused filament fabrication, FFF, which is a similar process with a different name. The most commonly used thermoplastic materials for FDM are ABS, acrylonitrile-butadiene-styrene, and PLA, polylactic acid, although many other materials can also be used. FDM machines range from small desktop units to large industrial systems that can produce objects that are several feet tall. FDM is a popular 3D printing technology because it is relatively inexpensive, easy to use, and can create complex geometries. FDM is also used in rapid prototyping, where physical models are quickly produced to test designs before committing to more expensive production methods. FDM machines use a 3D model created in computer-aided design (CAD) software, which is then sliced into thin layers and sent to the printer for production. FDM machines can produce objects with layer heights as thin as 0.05 mm, depending on the machine and the material being used. FDM machines can also produce objects with a variety of surface finishes, from smooth to rough, depending on the settings used during printing. FDM machines can print objects with internal cavities and intricate details, making them ideal for creating prototypes of complex parts. FDM machines can use multiple materials and colors, allowing for the creation of multicolor and multi-material objects. FDM machines can also produce functional parts, such as gears and brackets, that can be used in mechanical assemblies. FDM machines can produce objects with high accuracy and precision, making them suitable for use in medical and dental applications. FDM machines can be used to produce objects with a range of mechanical properties, including strength, flexibility, and heat resistance, depending on the material being used. FDM machines can produce objects with high resolution, which is a measure of the smallest detail that can be accurately reproduced by the printer. FDM machines can produce objects with a range of infill densities, which is the amount of material inside the object. FDM machines can produce objects with a range of surface textures, including smooth, matte, and glossy. FDM machines can produce objects with a range of colors, including opaque and translucent. FDM machines can produce objects with a range of sizes, from small models to large sculptures. FDM machines are widely used in the aerospace, automotive, and medical industries, as well as in the production of consumer products. FDM machines can be used to produce complex molds and tooling, which can then be used to produce parts using traditional manufacturing methods. FDM machines can be used to produce custom prosthetics and implants that are tailored to the individual patient. FDM machines can be used to produce architectural models and prototypes for buildings and other structures. FDM machines are continually being improved, with advances in materials, software, and hardware, which are making the technology even more accessible and versatile.